Good day, everyone, and once again we're back together. Your favorite uncle on dial, and of course, I know that you guys have been working hard just to make sure that you get those good results. All right, so if you are new to the channel, please just make sure that you subscribe, and obviously at the end of the lesson, just hit that like button, and please just share it to as many people. Tell them that your favorite uncle is always making sure that you get good content when it comes to maths and science. And of course, you can get in touch with us. All our details will be on the description of this video, as well as you can visit our website. That's www.mlungisiNkosi.co.za to download the latest question papers. All right, so today we are covering the fundamental counting principles. Right, I know many of you have been asking us to, just make sure that we have that lesson available, and the time has finally come. All right, so I hope that you will enjoy this lesson. Let's go right into it. All right, now let's consider the fundamental counting principle. Right, so what we're going to do is we're just going to look at the rules as we go along. Okay, so we're going to consider just the possibility and then talk about the rule thereafter. Right, so let's talk about the first one. Right, so suppose in this case, we are going to be specifically looking at independent events. So in this video, I'm going to be considering independent events, okay? And of course, I'm going to consider events that are occurring one after the other, meaning events that are not occurring simultaneously, right? So it will be independent and not simultaneous in this particular case, right? Simultaneous. Okay, right. So in this case, let's consider the first possibility. So suppose that I have, let's just say for argument's sake, I've got t-shirts, right? Okay, so let's say you've got, first of all, a black t-shirt, okay, and you've got another red t-shirt, and you've got another, let's say maybe blue t-shirt, right? Okay, so I've got another blue t-shirt. Okay, so in this case, let's say you also have pairs of pants, all right? And just for argument's sake, again, you've got a black pair of pants as well as another blue pair of pants. Okay, right, there are my pants there. All right, now the question is, if you've got three t-shirts and then those two pants, how many sets or how many ways can you wear these clothes? Now you think about it. You can wear the black pants with the black t-shirt. You can wear the black pants with the red t-shirt. You can wear the black pants with the blue t-shirt, right? But also you can wear the blue t-shirt, right, with the black, the blue with the red, as well as the blue with the blue, right? So in this case, if I were to look at the number of ways in which we could have these combinations, so how many would I have? Well, think about it. So you have two pairs of pants. You've got either the black or let's say black or blue, right? So in this case, you can wear the black pair with, okay, let me just change my color there. So you can wear the black with the black t-shirt, okay? So that's the black t-shirt, all right? And you can wear the black with the blue, and you can wear the black with the red. Okay, right. So let's call this this first possibility black and black. Okay, let's call this black and blue. So if you don't mind, I'm just going to say B dash for blue. And I have black and red. So that's B and R, right? But then again, as I said, I could have the same thing in this case with the blue pants with the black t-shirt. I could have the blue pants with the blue t-shirt, but I could have the blue with the red. Okay, so in this case that would be blue. Okay, remember we said blue would be B dash, and then that's black. And I would have, in this case, blue with blue, okay, B dash and B dash, as well as blue and red. So how many possibilities can do we have, right? So we've got 1, 2, 3, 4, 5, and 6, right? So meaning that the number of combinations that we can make, right, formulates what we call rule 1 of the fundamental counting principles, right? And rule 1 simply says, right, and I'm going to show you just now, it says, well, where we have m ways, all right, where we have m ways to achieve one thing, to have one thing, right, and we've got n ways of another. So what we can do now is that, all right, so n ways of another. So it means there are n, therefore there'll be n times n ways. So therefore there will be n multiplied, or rather m times n ways for both. Okay, so that's the first rule that we are going to apply. So look at this. We had 3 t-shirts, and we had 2 sets of pants, in this case pairs. So in this case, how many ways could we wear them? So all we simply did, or all we could do, is just simply say 3 multiplied by 2, and that gave us 6. Okay, right, so that's the first rule, right? Notice in this case, we did say that, the pairs of the pants and, the t-shirts, obviously in this case, those are solely independent. And so what this simply means is that we can actually apply this rule, right? Now, we're going to go into rule number 2 of the fundamental counting principles. But I want to first just give you a possibility, right? So let's say we are going to seat people, okay? So we've got chairs, all right? So I'm not very good at drawing. So let's say we've got chairs. So I've got chair 1, chair 2, chair 3, chair 4, and chair 5, okay? Right, now let's just say, for argument's sake, you've got 5 children that have to be seated in those seats, right? What are the different combinations or possibilities, or what are the different ways in which you could get those children seated, right? So think about it. So in the first chair, what you've got are the 5 children. So you can place any of them in the first chair. So you've got 5 children there, okay? But now remember, you already have 1 seated in seat 1. So that means now in chair 2, you've got 4 that are remaining. Okay, right? So now you've got, in this case, 4 that you can choose from. Okay, so in this case, in chair 3, so you've got how many? You've got 2 already that are seated. Now you can have 3 of them that you can choose from. And then in chair 4, obviously, you've got 2, and you've got 1 in the last one. Okay, right. So remember, you had 5 possibilities in chair 1. You've got 4 possibilities in chair 2. You've got 3 possibilities in 3 rather. You've got 2 possibilities in 4 and 1 possibility in chair number 5, right? So what this means is that where we've got an n number of ways to do the same thing, what we can simply do is just simply multiply those. Okay, so what we simply say is that the number or the combinations that you can have is a product of all those natural numbers in this case. And by the way, we call that a factorial, right? So in this case, it means that n factorial, simply, when you've got n factorial, what you simply do is that it means that in this case, it's a descending number of natural numbers, right? All right, descending order of natural numbers. It's a product of descending natural numbers, right? So in this case, what we simply are saying is that if, so where there are n ways, okay, so n different ways, so if there are n different ways, or rather n different things, and let's put it that way, right? So if we've got n different things, okay, that we can arrange, or to where we can have it placed, right? If n different things can be placed in n different ways, okay, or n different positions, let me rather put it that way, right? So if I've got n different things that I need to place in n different positions, so note in this case they are both the same, the number of objects and the number of positions are equal. So in that case, it means that what I will have as a combination, or rather the number of possible outcomes that I will have in that case, will basically be n factorial. Okay, right. So in my case, where I was considering the number of children, right? So in this case, what it simply means is that you would simply say that's 5 multiplied by 4 multiplied by 3 multiplied by 2 and multiplied by 1, and you'll see that this is equal to 120. So that means that 5 factorial in this case is 120, right? So remember, so that means that if you've got 7 factorial, you'll say 7 times 6 times 4 times 5, times 3 times 2 times 1, and that is what you would essentially get. Okay, now please remember, we still are saying these have to be independent events, right? Now in this case, now let's go continue to the third rule, right? So if in this case, suppose that we had for instance, runners were participating in a marathon, right? So there we are, we've got a marathon, and we've got 8 runners that are participating in that particular marathon, right? So we want to make sure that 3 people win out of that marathon. Now notice, we've got number of people is 8, right? So if you have 8 runners, okay, so let's take 8 runners, all right, and in this case, oh goodness, our writing, so if we have 8 runners, but in this case, out of the 8 runners, only 3 winners can emerge, right? So what would we do in that case? We would say, look, we know that there's 8 factorial ways in which we can achieve that, right? But in this case, remember, we only have 3 positions, right? Now, rule number 3 simply says, now notice, so we're going to rule 3. Okay, so rule 3 would simply say where there are, where we've got n different things, right? All right, that have to be placed in okay, so that have to be placed in R positions. Notice now the difference, okay? So we've got different number of things, and we've got different positions, right? So R positions, right, the number of arrangements in this case, so the number of arrangements, right, will just simply follow the following, okay? So we're saying in this case the number of arrangements is, so now we'll say, well, it's n factorial divided by, now notice we'll have n minus r factorial. Okay, right, now let's go back to the issue of runners. So we said we've got 8 runners, okay, but in this case we've got 3 positions, so we can only have 3 winners, right? Think of the Olympics. So in this case, what are the number of arrangements that we can have, right? So we would say, all right, so in this case, we've got a total of 8 runners. So that would be 8 factorial divided by, notice in this case, you'll have 8. How many positions do we have in this case, right? We've got 3 positions, right? So that would be 8 minus 3, okay? And that would be our factorial. So what does that mean? Okay, so that means at the end of the day, we would have 8 multiplied by 7 multiplied by 6, okay? So notice in this case, we would continue and say multiplied by 5, multiplied by 4 times 3 times 2, right? Times 1, okay? I don't have enough space there to say times 1, but divided by, now what is 8 minus 3? That would give us 5, right? So that would be now 5 factorial. That would be 5 times 4 times 3 times 2 times 1. Notice that this entire thing here cancels with that whole thing over there. So what do you actually end up having? You end up having 8 times 7 multiplied by 6, and in this case that would mean that you've got about 336 ways in which the winners can, or the possibilities that can come from our winners. Okay, right, so please note in this case that the number of possibilities and the number of positions are not the same. So in this case we simply say it's going to be n factorial divided by n minus r factorial. Right, now let's go on to rule number 4. Okay, so we simply are saying in rule number 4, so suppose that we were seating people, right? And I'm making an example with seating. Okay, so suppose that we are going to be seating people in rows, right? Okay, so yeah, I'm just going to make an example with boys and girls, right? So suppose that we're seating a B number of boys, right? So we are making a seating arrangement. Okay, so we're making a seating arrangement. But in this case, we are seating B number of boys. Okay, and we are seating, and we're seating G number of girls. Okay, G number of girls. All right. Right, and we have to seat them in a row. Now, I'm going to actually consider different possibilities in this case, right? So now we say the number of possibilities, and I'm going to show it to you just now. The number of possibilities, or the number of arrangements that can be made in this case. All right, the number of arrangements will be as follows, right? So if we want them to sit in order, and I'm going to show you this later on. So if we want boys and girls in order, okay, boys and girls, in order, okay. So in this case, it means that we are not putting them together, not all the boys together. We're just sitting, we're just taking all of them. So in this case, what we would do is that we just take the sum of the boys and the girls, and we take the factorial. All right. So remember, so it means that if you place them in any form of arrangement, in this case, you are just not considering that it's a boy or a girl. You're just taking them as as they appear. So in this case, what you're going to do is just take the sum of the two, and then just take the factorial. But I want you to think about it. Now, if then we impose a restriction, We now have conditions, right? We say, look, you must place boys together, and or rather, yeah, you must make sure that boys are seated together and girls are sitting together. Right, now I want to just quickly just show you a combination here. So if we have boys and girls that are sitting together, okay, now I want you to think of it, right? Let's take an example. So if I had, let's say, 3 boys and 2 girls, right? So there it is, and I want them to sit together. So it means I'd have boy 1, boy 2, boy 3 over here, and then I'd have the girl 1 and girl 2. So that's my first possibility, right? Okay, but notice in this case that I could also have said, look, in my seating arrangement, I could still have girl 1, girl 2, right? They're still sitting together. And I've got boy 1, boy 2, and boy 3 over here. Now remember, in this case, when it comes to the girls, you can swap them around. When it comes to the boys, you can change them around, and so on, right? So in this case, what it simply means is that if I want them to be together, now please, I want you to notice, right? So it means that I am simply going to take 2, right? Because remember, there are 2 ways. We said in this case there are 2 possibilities. Either you start with the girls or you start with the boys. So that would be 2 possibilities. But in this case, it simply means that you are taking the boys factorial multiplied by the number of girls factorial. Okay, right. I hope that makes sense. So in this case, remember, because there are 2 possibilities and we are taking the boys and the girls separately, right? Now, let's take another example. So in this case, what it would mean is that you would simply say the number of arrangements that can be made would be 2 times 3. Remember, we had 3 boys multiplied by 2 girls in this case, all right? And you get, obviously, the factorial number there, right? So that would be the number of arrangements that can be made. Now, this one is just slightly on the tricky end, but I want you to please just hear me out on this one. Now, imagine if I said, now I only want the girls together, right? So I only want the girls together, right? So it means that it doesn't matter how I arrange for the boys. I rather arrange the boys, but every single time. In fact, you know what? Maybe to make it easier, because we only have, because we've got only 2 girls. So let's rather say, if I said only boys together, right? Now, what would I have? Now, I want you to really think about it. So we can have a possibility. So we remember we've got 5 seats in this case. So I can have boy, 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 and girl, girl, right? So only the boys together. So it does also include, girls being next to each other, right? Or I could have, now please, I want you to note, I could have girl, right? But remember, boys have to be together and the other girl sitting on the other side, right? So there I am. I've got my boys still together. Alternatively, what I could still have are the girls together, and in this case with boy, 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 right? So that's another possibility. So notice in this case, how many different arrangements, or how many different possibilities could we actually have, right? So in this case, what you would do, remember, we could still arrange the girls and the boys differently. Now notice, right? So what this would mean is the following, right? Remember, I said only boys together. So that would mean that if I take the boys, right, it's going to be girls plus 1, okay, factorial. I want you to note. And where does the plus 1 come from? from the fact that there were 3 different ways in which I could arrange the girls, right? Either next to each other from on one side, separately on either side, and in this case I could place them next to each other starting with the girls, right? So it means that it would be the +1. So in this case I've got 2 girls, but in this case I've got 3 ways in which I could arrange them, okay, multiplied by the number of boys factorial. Okay, so I want you to note in this case what we are simply saying is that it would be girl +1 factorial multiplied by boys. Of course, if we had to also say only girls placed together, okay, which is what I wanted to start with in this case. If I only place the girls together, I want you to note in this case what I could have is, of course, girls here, and I would say, well, boy over there, okay? Or what I could have is the first girl and boy, and with a girl there, all right? Or rather, sorry, we said only girls together, sorry about that. So in this case, I would have another possibility would be boy, okay, girl, and boy over there, right? So now I can separate the boys, but the girls still need to remain together, right? So in this particular case, you can still have boy, right? And I could have girl with another boy. So in this case, you can see the different combinations, or I could have boy, girl over there, and now I end up with 4 different possibilities, right? So what this would mean is that if I were to take the girls together, right, so this would mean that I take the number of boys +1 factorial multiplied by the number of girls. Okay, so that is in fact my 4th rule. Okay, right. So what I would like for us to do is just to continue with this now, just to give numbers to this. So that would mean if I were to take in my first possibility, remember we said if we took only the boys together, how many girls did we have? We had 2. So that would mean this would be 2 + 1 factorial multiplied by the number of girls, in this case factorial. So I'd have multiplied by 2 factorial in that case, right? Whereas in this case, remember the number of boys was 3, okay, +1. So in this case 3 + 1 factorial plus in this case the number of girls, which is 2. So that would be multiplied by 2 factorial. All right, I hope that makes sense. All right, now let's look at our first example, and obviously we're going to try and transition from that, and then obviously in our next video we're going to be talking about a different set of examples, right? So they say 3 girls and 4 boys have to be seated on 7 chairs, right? They say calculate the number of ways that they can be seated if, all right? Now the first way they say if there are no restrictions. So it means that we're just simply going to seat them in any particular order, all right? So how many possibilities or how many ways in which they can be seated in that case. So remember, if there are no restrictions, in this case, all we're going to say is, well, it's the number of girls plus the number of boys. So this is going to be 3 + 4 factorial. So it's simply going to be 7 factorial, and that would be equal to 5040. Ooh, that's a huge number. All right. So now they say if the 2 genders must sit together. All right. So we've already looked at this, right? And we said if they have to be seated together. Now remember, we can either start with the girls or we can start with the boys. or we can start with the boys or the girls. So in this case, what we're simply going to do is say, well, it's going to be, in this case, 2, or you can say 2 factorial multiplied. So this is the number of genders that we have, right? Multiplied by the number of boys. In this case, that would be 4, okay? And multiplied by number of girls, that's 3 factorial. Okay, so you're just simply going to say, well, remember there are 2 genders, there are 4 boys, there are 4 girls. In this case, or by the way, that you can also look at, how many swaps can you make, right? So you can only start with the girls or the boys, in this case, or you can start with the boys, then the girls. So the number that we get there is 288. Okay, right, so let's look at the next one. They say, if only boys must sit together. Right, so we've had a look at that, right? So you can either have boys sitting together, starting with the boys first. So then you can say girls, girls, girls. Or you can say this is boys, or rather girls. Let's start with the girls. So only boys sitting together. So girls, boys, 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 and boy, and girl, girl, right? And of course you can look at girl, girl, boy, 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 and another girl, and so on and so forth, right? So remember, we said if it's the other one, so if you remember our example of the 4th rule, right? So we said if it's going to be the boys that are seated, okay, together, then you take the number of girls and you say plus 1, right? So this is simply going to be, the number of girls is 3. So I'm going to say 3 plus 1 factorial multiplied by the number of boys factorial. Okay. Right, so it means you'll end up with 4 factorial multiplied by another 4 factorial. And in this case, that would give me 576. Okay, so that's the number that I get, 576. Please just make sure that you know where the factorial is on your calculator. Okay, if you're using a particular brand of calculator, it's usually at that inverse function, but in this case you'll just press shift in that case, right? So you'll say shift and then that inverse, so you'll see at the top there you've got that factorial sign there. Right, now they say to us in the next one, the boys and girls sit alternately. So it means that it must be boy, girl, or the other way around. Now, in this case, the only way, if you think about it, in which they can sit alternately is if you started with a boy, right? Because if you start with a girl, there might be 2 boys that are sitting next to each other because the number of boys is much bigger. So you must have boy, girl, girl, boy, girl, and boy, right? So there's only one way in which you can sort of arrange that. It must only be a boy that's starting, right? So what we are going to do in this case, now please, I want you to notice. So in this case, it means that we only have one possibility or one entity in this case in which we can arrange it. But of course, we can change the number of boys. I mean, you can put boy 1 or boy 2 first, or boy 3 first, or boy 4 first. So what you would have is, it would be one entry or entity multiplied the factorial number of boys multiplied by the factorial number of girls, right? So in this case, that would simply mean this would be 144 possibilities. Okay, right. That's what I get. So now, the last one that they say the youngest girl, boy and girl must sit together. Right, now I want you to just think about it. So it means there must be a boy and a girl that are seated together, right? So in this particular case, it means that we'll have, let's just say for argument's sake, the seat here, boy, girl. or boy 1, girl 1, and thereafter you've got all the others that are following, because already that one seat has been taken, right? Or rather that those two have to be together. So you'd have, so this would be boy 2, boy 3, boy 4, and you've got girl 2 and girl 3, right? So now, in this case, I want you to note, how are we going to go about this one? So it means that we can arrange, now how many arrangements do we have? We've got 1, 2, 3, 4, 5, and 6, right? So we've got 6 different arrangements, right? And in this case, as we have 6 different arrangements, in this case, it simply means that when we look at it, okay, now think about it. These ones, we take them as one item because obviously they have to be seated together, right? But within that, also we still have these ones that we can swap around, right? And there's only 2 of them that must be seated together. So it goes without saying that in this case, what we're simply going to have is 6 factorial, because obviously we're going to seat these separately, okay, as well as multiplied by, in this case, the ones that are inside here, that's going to be 2 factorial. Okay, so if I say 6 factorial multiplied by 2 factorial, in this case, that would give me 1440. Okay, so that is how I would answer those kind of questions. I hope that that has been really helpful. All right, so in our next video, what we're going to be doing is just looking at combinations, words, and so on. And of course, we're also going to be looking at non-independent events, right? So in this case, we're going to be looking at, when we've got dependent events. All right. All right, and we've come to the end of our lesson. So in this case, please don't forget that at the end of every lesson, there is a super thanks feature. You can get it right at the bottom there. Okay, and where you can just give a monetary gift to your favorite uncle. And of course, what we also can do is that if you need to watch the lessons in a sequential manner, you can always go onto our playlists, right? Please have a look at that playlist feature and just make sure that you are able to follow that from our channel. All right, and please, ladies and gents, remember to subscribe. We really want to get to that epic 100,000 mark. We are almost there, and we will get there, but obviously through your subscription. And of course, you can visit our website where you can get some value-added services. You can get past exam question papers there. You can get our courses that we are offering. And of course, you can get in touch with us. All right. All right, ladies and gents, we've reached the end of our lesson. I hope that you've really found this lesson very helpful, and of course that it will assist you towards your preparation. Of course, in our next lessons, we'll be looking at non-independent events, and we'll also be looking at combinations, words, passwords, and so on. Right? Please just make sure that you hit that subscribe button if you haven't already. And of course, you can leave a good comment. If there are any questions, you're more than welcome to leave a question. I always try to respond to your questions. All right. Otherwise, from me for now, please continue to follow your favorite uncle, and he'll continue to be your plug. From me for now, it's Sharp Sharp.